Hello friends, welcome back to episode 8 of DevOps series. So in this session, we are going to cover the side-by-side comparison between the Docker and the Kubernetes. So in the previous two sessions, we have covered the concept of Docker and Kubernetes in detail. Okay, so now in this particular session, we are going to do a side-by-side comparison. Okay, what exactly is a Docker and what exactly is a Kubernetes, and what are the different kind of scenarios and conditions where we use specifically the Docker and Kubernetes. Docker and Kubernetes. Okay, and there are multiple kind of queries. What exactly we do with the Docker, and what we do in the Kubernetes? What is the bit difference between them? Can we deploy the applications in Kubernetes? Okay, so there are multiple kind of questions and queries. So I'm creating this session, okay, to clarify all the doubts. Okay, and this one session is sufficient for you to make a difference between the Docker and Kubernetes, and along with that, you will get some understanding of Docker and Kubernetes as well. Okay, so now let us start with the Docker first. So what exactly is a Docker? So I'm sure you must heard about that Docker is a containerized solution, right? It is a containerized solution. So what we do, we create the containers in the Docker, correct? Now, what is a container? So you can consider it in by taking the example of a real life. So what are the containers that basically we use in the shipping industry? Okay, to transport the products from one location to different location, right? And now the product that we that contain inside the containers, okay, or you can say that we ship in the containers, okay. So there are a variety kind of a products. There are different kind of a shape and size of the products. It could be small, it could be big, it could be large, it could be horizontal, it could be vertical. So irrespective of the size of the products, okay, we have a very standard size of the containers, right? There would be a specific size of the container, right? And now inside that container, irrespective of the size of the different kind of a products, we just pack all the products inside the container, right? And then we ship it to the different locations, and in that location the container is just get unloaded, and then we take out all the products from the container, right? So that means we have a standard way of shipping all the product irrespective of the size, that is with the help of containers, correct? Similarly, if you compare it with the software industry, okay, so that container, it contain all the software applications and all the dependencies, and this is the definition you will learn about the Docker everywhere. Docker is a containerized solution, and in a container we have a software, we have application, and we have dependencies, right? So software, we know about that one. For example, let us take the example of a web server. It could be an application server where you have deployed the multiple applications. In the web server, you may have deployed your web applications, right? And you may have a database as well. You have installed the database, okay, and along with that you need the dependency. So what are the dependencies are certain kind of a operating system level files or different kind of a libraries, right? So all the softwares, multiple times or multiple software depend on the different kind of a OS libraries, right? And along with that you will have your own software specific libraries as well, right? So that means when we say about a container, okay, so this container contain your all the software. That means it will contain the complete software, web server, application server, database. Along with that, if you have some specific code, it will contain your all the code, right? And along with that, it has a dependencies. So all these things are packed in the containers. Now what is the benefit of that one? For example, if I say that you have two environments, one is a development, second is a testing, right? And you need to configure the environment where we need the install the web server, we need to install the application servers like WebLogic, WebSphere, JBoss. Then we need to deploy our application, then you need to configure the different other multiple resources of your application servers. You need to install the database, okay. So all these things you need to perform in your development environment. Now if you need to do same thing on the testing environment, then you will follow the same exercise here as well. Whatever the manual step that you have done here for the installation and configurations, everything you have to follow in the testing environment as well, right? So is there any way to simplify this process, so I do not have to follow these kind of a repetitive task in each and every environment, because today I am talking about the development testing. Tomorrow you have to go to the quality, you may have go to the pre-prod, and then there would be a production, right? Now you can consider how much time taking it is, right? And multiple time it has happened that when we develop the code in development and when we move it to testing, okay, then we get a lot of time complaint that the code is not working. Okay, even the code is working in the development environment, but it is not working in the testing environment, right? That could be due to multiple dependencies may be missing. It could be your OS level dependencies, it could be your application level dependencies, right? So to avoid these kind of a problems, or to save this all these kind of a times that we need to for the repetitive task in each and every environment, we have the solution which is called the Docker. And Docker is one of the containerized solutions. The Docker is not only the containerized solution, there are multiple other containerized solutions as well, but Docker is one of the leading containerized solution as of today, right? So what we do actually in the Docker, we create the containers. Okay, so this container, suppose I have created this container, this contain my web server, it contain my application server, I have deployed the files, right? And I have my all the dependencies are copied here, and along with that I have the OS level dependencies. Okay, so each container contain a lightweight OS image as well. This is called the lightweight OS image. Okay, and this lightweight OS image contain all the dependent libraries that your application need, right? For example, you may have a multiple lib folders in your Linux platform systems, right, which is installed with your operating system. And then the software that you install, whatever the dependent library files are there for a particular software, we copy inside the lib directory, right? So this lib directory will also be copied inside your container. It will be exist inside your container, which is a part of your lightweight OS image, correct? So now in a nutshell, we have a container which contain our applications, which contain our software, and which contain all the dependencies. Okay, and these dependencies in the form of lightweight application server. So now, instead of doing the same setup in each and every environment, what we can do, we can take this container, okay, and we can just deploy this container to the different environments. So that means we need to build it one time, maybe in one container. After that, you can just spin up multiple containers using this particular image of the container in the multiple environments, right? So now what will happen, your time will same. You don't need to do all these kind of installation configuration of your software applications multiple times. You have created one container and you need to just initiate to replicate this container in the multiple environments, right? The other benefit is that if you have configured one container and tested everything here, okay, then it is guaranteed that it will work on each and every other environment, because this is the container which is going to be deployed along with all the dependencies we have tested here, right? So this kind of issues that we were talking about, the code is working in development, now it is not working in testing, there is no chance of the such kind of situations in the Docker, because we are going to deploy this specific container which contain all the application software and dependencies which we have tested, and the same is going to other environment just like a package. You can say it is a package, or you can refer it as a container as well, right? So this is the containerized solution, and Docker is one of the leading containerized solution where we contain the containers which contain the application software and all the dependencies, right? Now let me extend the discussion. Okay, so now you have a complete clarity on what actually is a Docker. So in a Docker, what we have a containers, right? So now specifically in the real-time production environment, we can have multiple containers, not a single container, right? For high availability, failover, load balancing, and based on the number of users we have. Okay, in an enterprise world, you can have a multiple containers, right? And each container will have the same set of copies. That means if we have a one container, which we have built and tested, the same container you are going to replicate everywhere. Correct? It has to be a similar copy. And why we have the multiple containers? That is for the high availability. And then scalability, failover, and many things. Right? This is the practical scenario. Now, what is the challenge here? If suppose that the containers are growing, today you have a 2 containers, maybe tomorrow you have a 4, then 10, 20, 30, 40, 100, and maybe in thousands. There are many enterprise business, they are running thousands of the containers as of today. Okay. Now, if you are in this kind of situation where you have multiple containers, how you are going to manage all this? If suppose that I will tell you that, okay, I have done some changes in my code, right? So this is my primary container where I have done the change in my code. Now this code need to roll out in each and every container, right? And now suppose that you have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So here we have a 15 containers, only 15. Now how you are going to replicate this container to everywhere? Are you going to manually initiate this kind of a rollout of your code in each and every container? Right? You have to maintain the high availability. So that means each time you have to shut down one container, you need to replace it with another container. And the same exercise you have to repeat for other as well, right? Shut down the container, then roll out your new container, right? And suppose that if you encountered some issues with your the code or the logic that you have deployed and you want to roll back it, then again you have to go in the same situation. You need to roll back one by one each and every container, right? And if it is in hundred and thousand of containers, how you are going to manage that? It is not feasible to do manage all these containers manually, right? So for this kind of a management, we have the one solution that is called the Kubernetes. So Kubernetes is an orchestration solution only. Now what is the meaning of orchestration solution? It just manage your containers from a central single location. So as I said, I explained the one of the basic challenge when you have a multiple containers, right? How you are going to deploy your application and then how you are going to roll back if you have multiple containers. That was one of the challenge. Okay. So your Kubernetes is going to help in that case. Your Kubernetes, as I said, is an orchestration solution. So it make a cluster of all the your containers. Okay. And then every containers, all these containers you can manage from a single location. From a single location you can manage all these container, and this single location is your Kubernetes. This functionality is enabled by your Kubernetes. So now the biggest difference between Kubernetes and Docker is a containerized solution where we have the complete application, software code, and then dependencies inside the containers, right? But Kubernetes is just an orchestration solution. So it is going to manage your multiple containers. So not only Docker, even you have some other orchestration solution, sorry, you have some other containerized solution, because there are multiple there in the market. Okay, so Kubernetes can manage all these containers from a single location. Now one of the challenge that I was talking about, how you are going to deploy your uh, modified container, or how you are going to replace the other containers with the modified container if you have the 100 and 1000. This can be taken care by Kubernetes. This is one of the feature of Kubernetes. You can initiate the deployment of your code in the container from a single location, and you'll automatically get one by one deploy in each and every container whatever you have in your cluster. So in Kubernetes we can create a cluster. Cluster is a group of services, and here when we're talking about cluster in the Kubernetes, so that means it is a cluster is a group of multiple containers. Simple. And all are running the similar application, right? So this is a cluster which contain the multiple your containers. Right. So now let me explain you some benefits of Kubernetes, so you will get a complete proper understanding of that. Okay, so let me open a new whiteboard, okay, to explain you properly. Okay. So now hope you are clear on what exactly is Docker now and what exactly is the Kubernetes. So Kubernetes is just an orchestration solution to manage your multiple containers. Now what are the benefit? Okay, so before benefit, let me tell you the architecture. So simple, you have the first you have the Docker. Okay, I am just taking the example of a Docker because it is a leading container solution. It could be anything. It could be any container. So you have a Docker. On Docker, you can create the multiple containers, right? And all these containers are going to be managed centrally with the help of Kubernetes, which is also called as K8s. Correct? Now, this Docker could be on the multiple machines, right? For the high availability. So, this is my machine or server 1, Mac 1. This is my machine 2. This is my machine 3, and this is my machine 4. I have 4 machines, and each and every machine I have a Docker running. And with the help of this Docker, I have created multiple containers. 4 here, 4 here, 4 here, and similarly the 4 containers in the all the machines. Now we can have the Kubernetes K8 cluster where we can manage all these containers which is running on the different machine from a single location. Correct? So now what we are going to get the benefit. So before that, let me tell you a very small basic concepts which is called the pod. I am sure you must heard about the pod, and many times I have seen the multiple engineers are confused on the Kubernetes. What exactly is a pod? Okay, so pod is nothing but simple. It is a group of containers. For example, this is a machine one. So here we have one pod which contain 2 containers. Similarly, you have another pod which have 2 containers. So simply this here pod is a group of containers for the easy management of the containers. Right? Now what are the benefit we are getting? So one, we have learned that it is a orchestration tool. With the help of that, we can do the centralized management of all the containers, multiple containers, which is not possible to do manually one by one. Right? So the one or first benefit of this Kubernetes in the container solutions is auto scaling. That means it can automatically scale up the number of containers, and it can easily scale down the number of containers. Right? So what does it mean? In a production, it could be possible that around for a day 24 hours, for around 18 hours, the load is minimum in your system. Then you need only 4 containers. Right? Now for rest of the 6 hours of the day, you need at least 8 containers because this is the peak hours when you have heavy traffic in your system. So what you can do for this 18 hours, you can run only 4 containers. But during this peak period where you need the 8 containers, you can spin up 4 more containers only for that duration when we have the peak load. Correct? And then when the load again is down, you can scale down your number of containers again to 4. So this is called the auto scaling, and this auto scaling is possible with the help of Kubernetes. You can configure your Kubernetes for this auto scaling, which is scaling up and scaling down. Second benefit is load balancing. So that means if you have multiple containers and you need to distribute the requests equally between all the servers or all the containers, right? So for that, your K8 is there, plus Kubernetes is there. So request that is received by your Kubernetes cluster, it is distributed equally based on the algorithm that you are going to select between the multiple containers, which may be running on a single server or it may be running on a multiple physical servers. So this is the second benefit of the load balancing. Third is called the self-healing. It is very clear from the name as well, self-healing. That means if any of the container is not healthy or not responding or crash due to any reasons, your K8 cluster or the Kubernetes will automatically spin up a new container instead of that. So as I said, in a cluster or in this example, okay, you need the minimum number of 4 containers always up and running to maintain the load. in the system, right? Now suppose that if any time one of the container crashed or not responding due to any reasons, you will have only 3 containers and your application may suffer in that case. So your Kubernetes cluster will always check the health of each and every container, and if any time it look for the minimum number of containers is expected to be 4, but at any time if it sees that the minimum number of containers in the cluster is only 3 because one is not responding, so it will automatically spin up one new container in your cluster to make it to the 4, up to the 4 level, whatever the minimum number of containers that you have defined. So this is called the self-healing or self-repairing of your containers with the help of Kubernetes. Next benefit is auto rollout and auto rollback. So this is the same example we were talking about. If you have multiple containers, how you are going to roll back the changes in your containers. You have one container where you have updated your code. Now you want this container should replace all the old containers with this new container because now we have a new code. So you can initiate this kind of a deployment, which is called the rollout, from the Kubernetes. So your Kubernetes automatically replace all the containers one by one in the rolling fashion. It will replace first container, then it will replace the second container, then it will go for third container, then it will go for fourth container. So in rolling fashion, it is going to replace your containers one by one. That means it is going to roll out the new code in the rolling fashion without any downtime. Now, if suppose that you have some issues with the container with the new code that you have deployed and you want to roll back, then again you can initiate the rollback and your Kubernetes will automatically take care of that one, and it is going to replace your current container with the previous container, and again in the rolling fashion one by one in the reverse order. So your application will not suffer any downtime and everything will be taken care by your Kubernetes, and there is no manual efforts required from your side, right? And the last benefit, important benefit, is about storage orchestration. Storage orchestration. So what is storage orchestration? There are many situations where we need shared storage between the machines. Like if you know that we have a multiple situation where we have a multiple virtual machines or server where we configure the shared drive, where we have a certain kind of a data that we share between the multiple machines. Now similarly, if you have a certain kind of a persistent storage requirement, okay, and where you need a certain kind of a shared storage between multiple containers, so this storage orchestration is provided by the cluster, Kubernetes cluster. So you can have a storage that can be configured or shared between the multiple containers as well. This kind of a storage orchestration also supported by your Kubernetes cluster. Okay, so these are the important benefits that we have discussed about the Kubernetes now, and I hope it is very clear to you now what exactly is the Docker and what exactly is the Kubernetes, what is the difference between them, what we can do with the Docker and what we can do with the help of Kubernetes, and what are the major benefit of Kubernetes and why it preferred when we have a container solutions in our organization. Then it is a must you have to use the Kubernetes, specifically when you have a lot of different multiple containers are running in your organization, right? So if you have any query, question, any doubt, or any kind of a thought in your mind which you would like to discuss, okay, then you can write to us digitalk.fmw@gmail.com. Okay, you can write to us anytime, any kind of a query. We'll try to respond to that as soon as possible. If you would like to join our Udemy course, then you can visit https and then digitalksystems.com, and there you will find our Udemy course link along with the coupon code. And if coupon code is expired, then you can write to us on this particular email ID and we will send you to the revised new code. Thank you.